there. Welcome to the show. How's it going?
Good. How about you? And I know you
Please.
guys are on from past 4 hours or so.
That's right. That's right. I wouldn't be anywhere else in the world.
Likewise.
I love it. Please introduce yourself to the audience. Tell us a bit about what you do here at AWS.
Sure. Hello, everyone. I'm Mani Tanuja, Senior AI/ML Specialist Solutions Architect at AWS. I primarily work with Amazon SageMaker, and I'm responsible for end-to-end machine learning, ML ops, which is primarily automating the entire machine learning lifecycle, and distributed training.
Wow.
So I cover a lot of things around SageMaker. And today, I'm primarily here to talk about Amazon SageMaker experiments and the new features that we have launched.
We covered this in some earlier sessions, but there are probably people who have joined us since then. Mani, can you give us just a quick maybe overview of SageMaker? And there's a lot of features inside SageMaker number one, right? There's a lot going on under the SageMaker umbrella. But could you tell us, why do people look to SageMaker to get started with ML? Why do they use it even when they're advanced? Like, who is SageMaker for, and what does it help them get done?
So SageMaker is basically for data scientists, machine learning engineers, even for business analysts to do machine learning. And it not just offers like machine learning, it offers, think of it, the entire machine learning lifecycle, where I have to prepare my data, label my data, do some data analysis on top of it before even I can start doing machine learning. And it's a fully managed service. You can train a lot of machine learning models, and it provides you with lots and lots of features to train your models, to deploy your models, to build your models. And not just that, it also comes packed with the ML ops capabilities, meaning that you can automate your entire machine learning lifecycle.
So it sounds like that's a lot of management it's doing for you, right? So we've gone from having to do all that yourself, right, and learn ML, to just being able to do ML and let SageMaker do the underlying work. And now we're on to like experiments, which is one part of SageMaker, right? So where does experiments come into this flow?
So whenever you are building machine learning models, right, or think of machine learning, it's not like very simple like other applications. The reason is that first you have data. So you have to experiment with different data sets, or even you say that today I have, let's say, 1 MB or 5 MB of data, and tomorrow I might have 1 gigabytes of data that I need to clean, prepare. And then once I get my data cleaned and prepared, I'm like, okay, let me just start building my models. Then there are a lot of ways that you would like to optimize your models. When I say optimize, is basically you must be tracking some kind of metrics to say, okay, how do I evaluate that this model is good for my application? So in order to optimize, there are a lot of hyperparameters. So think of those hyperparameters as like the knobs in a radio station when you're trying to tune in. So there are a lot of hyperparameters that you have to actually tweak or tune in. So what that means is whenever I'm using different sets of data or different types of hyperparameters, it's resulting into a different machine learning trained model, right? Which that model then I need to evaluate against my business metrics. So I need to track all of this, because when you're experimenting, it can result into hundreds of thousands of experiments. So how do I track those? How do I analyze it? And not just that, let's say I'm done with that, then I have to report it to my other stakeholders to make sure why I made that decision, right? So it's very important to have some kind of a tool which can help you organize, track, and compare these machine learning experiments.
Yeah, when you set out to do, and like you said, iterating across all these different types of data sets and training models, you're going to generate a lot of different experiments. But when you are building those experiments, what actually are you trying to learn from those? What is the outcome that you're looking for those when you're training a model?
Yeah, and let me share one slide on that. So
Yes.
it will just make it easier to understand, right? So you can see my screen, right?
You can now.
Yeah, now.
Okay. So when we are trying to create experiments, or what are we primarily looking at, right? So we want to log our metrics. That's one for sure, that how my model is training. For example, the metrics can be my accuracy, the loss that I want to reduce. So those can be, some of the metrics, and depending on which machine learning algorithm I might be using, it can be mean squared error and so on. So that's important. But I also want to log the hyperparameters which are yielding those metrics. So I will have a set of hyperparameters. And then I also sometimes might want to log some of the files, like data files, which I'm using to train my model. So it depends on my business use case, but those are the primary things that I'm looking at. How can I log my custom metrics? How can I log parameters? How can I log files? And sometimes think of it like all the model artifacts which are there, and I want to attach those with each of my experiments so that later on I can come evaluate those experiments. And even when my experiments, let's say I finalize one of the model and they are in production, I can come back and easily look into it. Okay, why was it there? Why it was better? What are my other artifacts? So you get everything in one place.
I might be getting ahead of myself. I usually am. But this mentions compare machine learning experiments. Does that also extend to me being able to compare, like if I've used different, I'm going to use the word algorithms because I don't know what the ML term for it is, but does that also flow into this, that I can take some data and my model and then compare the outputs of two different algorithms to see which one suits the data better?
Yes, you can.
Okay.
So there can be different use cases. One is, for example, I have a use case to do some image classification. So one can be, I have already selected my model and I'm sure that I want to use that particular machine learning model to do image classification. And then I will just, fine tune my hyperparameters or try with different hyperparameters and then say, okay, this is my best model. And sometimes it's like, oh, maybe I have shortlisted 2 or 3 algorithms and I want to compare those. So yes, you can do that. And you can log these metrics and parameters, which are basically key value pairs. So when you come back, you can see, okay, you know what? These are the metrics from different algorithms, and this is how I can compare. And I can visually see that my loss is less in this or my accuracy is higher in this, and this is the best one for me.
We've talked a lot in other segments as well around like in Glue data quality, for example. Earlier today, we talked about how important it is to have cleaned data or accurate data when building machine learning models. But one thing that, we've approached a lot of this from a technical perspective. One thing that this kind of raises in my mind too, of a question for those of us new to machine learning, like these two that you are now currently talking to, from a non-technical side, so to speak, it seems very important that you really have well-defined characteristics that you're looking for when you're going and building machine learning models, where you wanted to answer a specific question and there are correct answers to that question, and you're able to measure the correctness of those. And that's what is this tied to why you run experiments? Because you can experiment and find out which tweaks you do to the model tuning that produce more correct answers for your production. And is that an important piece of building machine learning models? Should you really set out with a clear, defined problem that you're looking to solve?
Absolutely, because that's the key. If you don't have a clear, defined problem, and sometimes you'll be surprised that framing the machine learning problem is the biggest thing.
Yeah, I imagine.
Because everyone wants to use machine learning to their applications, not just because it's a cool thing to do, because it can actually generate revenue for your business. And if you really want that, you first have to define the problem. You have to have some predefined objectives against which you want to compare. Because there is nothing called as 100% accuracy in machine learning, right? If it's 100% accuracy, you might need to check what's going on.
Yeah.
But you have to say, okay, what is my acceptable accuracy for this particular business case, which is good enough to go and which is good enough for my application to use and go and deploy that model into production. So for that, you need experiments. You can maybe once you run that model, you might get 70% accuracy, and then you want to fine tune, and your business is looking for at least 90% or over 90% accuracy. And then you will say, okay, let me just tune it more, try with different data sources, or maybe try different algorithms. So yes, it is very important to have a predefined problem or objectives against which you will compare.
I can also imagine, though, that this could come in useful from maybe you start out with a defined problem, right? Mm-hmm. And you run one of these experiments, but then you start to get the what ifs, right? So not just is this algorithm a better fit than this algorithm model? Is it model or algorithm? I don't know. But anyway, I'm going to say algorithm because that's what I'm more familiar with. Is this a better fit for the data than this one? Or is, what if we went in this direction, right? And then work that way.
Yeah, so there are different aspects when you are comparing different models. It's not just about the predefined metrics, Steve, as you mentioned. It's also about how my models can scale. Are they ready to scale? Maybe there is something state-of-the-art, huge machine learning model, but is it really important for my use case to just use state-of-the-art, biggest model that's out there? Sometimes it might be just too much for your use case. So what I recommend always to my customers is to start small, create small experiments, see if a machine learning model can help you solve your business case. That's perfect. You don't need to go into the deep learning side. But if it doesn't, then go to the deep learning models. You don't really have to jump and start with the biggest and the greatest, which is out there. If you need it, definitely go for it. But make sure that you're starting small. That's where you'll be more comfortable when it comes to scaling, how much infrastructure is needed, how many machines are needed to train that model, how is it cost effective, performance effective. So those are the things that we really need to understand when we are talking about machine learning and doing machine learning experiments.
I'm going to ask a question that will show that I'm out of my depth here for sure. It's a risky thing to ask because it may not mean what I think it means. Hopefully you'll forgive me if it's not a good question or a dumb question. So there's supervised learning and unsupervised learning. Does it make sense to run experiments on unsupervised learning? And maybe, just because I can't do it for sure, but maybe can you give our audience a rundown of the difference between unsupervised and supervised learning?
So when we are talking about supervised learning, we are saying that, okay, we have this labeled data. And then what we generally do is that, okay, we have this labeled data, we will divide our data into train, validation, and test sets. And then we started evaluating our models against the validation and the test sets, which we have kept on the side and not training a model on top of them, right? So that's how we do the supervised learning. So some of the metrics can be accuracy and loss and stuff like that. When you are doing unsupervised learning, then what we don't have is the labeled data. But even then, you would need certain mechanisms to say that, okay, whether this particular model is performing well or not, although the data is not labeled, it's working in a self-supervised fashion or unsupervised fashion. But you would still need some experimentation around that.
Okay. That's why I was curious, can you still reap benefits for running experiments with unsupervised learning, which it sounds like definitely not one or the other, right?
Yes, you can. But again, I would reiterate, it all depends on your business problem that you have defined, your objectives that you have for your application. So those are worth evaluating before we comment on, okay, whether it's needed or not needed.
Okay.
So how do people get started with this? I mean, what's it look like?
That's my favorite part. So Yeah, because I'm super techie and I love when people ask that, how do we get started? And what should we understand? So first thing is that with the new SageMaker experiments capability, it comes pre-built with SageMaker Python SDK, so you don't have to install anything. And with that, let me show you. So I'm in the SageMaker Studio. So basically, you go to the AWS console, you can go to domains, and then on the particular domain, you will have multiple users. So I'm not going to go into the details of domain and user. How do we onboard a user and a domain? There is very good documentation that you can refer. And then once you have set up the users, you go to the launch and click Studio. And that's where you'll be presented with something like this, right? With the launcher window, and this is the studio. This is your IDE, integrated development environment for doing machine learning. And there are so many features which are built into this. But what I will show today is basically the notebook. So you can go file, new, and create a notebook, but I have one open already for the experiment. So what you need to do is first you will import SageMaker experiment. And then when you write this statement with run, experiment name, run name, which is optional, the session you provide as run, it will create an experiment. And then you can log parameters or a single parameter, but they're key value pairs. You can log multiple parameters as well. You can log the entire file also. And when you do logging of the file, it uploads to S3 and then associate the S3 location of that file with your experiment. And if you notice, this is basically in the notebook. So you can log experiments, not just from the Studio IDE, but from any IDE which can access the SageMaker Python SDK. And then you can start creating your experiments, and you can load the same run. So in this case, I'm simply just providing experiment name and the run name and logging some parameters and logging the data files. And once you can just define your model, and you can then, when you are training the model inside the train model function, you can log the metrics, let's say loss or accuracy at each step. So step is a concept. You can have your step per epoch, or you can have it in, your steps can be iterations as well. So it depends on when you want to log particular experiment. So once you do that, then you can actually go to the home experiments, and you will see a list of experiments. So the reason I've mentioned this local, because I was doing experimentation on my local notebook. You can also do it as experiments in the SageMaker training job, processing job, or the transform job. And you can see multiple runs. Let me show you the experiment which has more runs. So this is the one, and then you can select and then say analyze, and you will say, okay, let me add a chart to it. Let's say we are evaluating its step and test loss. So then you can figure out
the comparison part of it.
Yes.
Okay.
Yeah. Once you have done the experimentation, maybe I've executed multiple models for this particular use case. So the example that I'm showing is basically using PyTorch MNS dataset for image classification. So it's a very simple model that I was building. And based on the different hyperparameter settings, I am presented with different models which have different test loss or the accuracy. And then I can just compare and create the analysis. And I can see it visually that, okay, which experiment is doing better than the other.
Oh, nice.
Yeah, it's pretty cool because, right? And then you can also create like multiple stuff like, I don't know, it's
well, it becomes even more and more useful the more experiments you have, obviously, right?
Yeah, absolutely. Because you cannot do this manually, right?
No.
And also, if you want to share it with your stakeholders, you click the download button, and that's your chart. So that's even cool that you can actually download this entire chart, add it into your report, and share it with your business stakeholders and see, that's the reason why I selected this particular model.
So you said earlier that this comes with everything you need, like libraries and things. You don't need to install anything.
No, you don't need to install anything apart from SageMaker. So you need SageMaker Python SDK,
Oh,
but you don't need to install any separate library, because in the older version, you have to install SageMaker Experiments, which was SM Experiments, but now you don't need that. Uh, you just need the SageMaker Python SDK, and it comes with it. You just need to import that.
Another thing too is you are in the SageMaker Studio environment currently, which is a wonderful place to be. Don't get me wrong, but we've got a lot of people that have a lot of opinions on other wonderful environments that they have grown to love over the years. You know, IDEs and things like that. Do you have to utilize SageMaker Studio to run experiments, or can you do that from other environments like another IDE?
Yeah, absolutely. You can use any IDE as long as you're using SageMaker Python SDK. You're good to go. You can log experiments with any IDE like PyCharm or IntelliJ, your favorite IDE, whatever you have, and then just start using as long as you can access the SageMaker Python SDK. That's it. That's pretty much it. But if you want to come and visualize it, then you have to come to Studio and visualize it. But logging experiments, working with the APIs, listing down different experiments, describing experiments, these are stuff that you can still do with the SDK.
We've got a question from chat around. So I'll just pop it in here too. It's not really about what we're talking about with experiments necessarily, but it's related to SageMaker. Is AWS planning on providing large NLP models like GPT-3 to build on and fine tune further models on top of? I know we have the Jumpstart feature, for example, right? I didn't know if you could talk to that a bit. I don't know about GPT-3 specifically in Jumpstart, but I wanted to give you a chance to talk about that feature if you wanted to.
Yeah, sure. So with the SageMaker Jumpstart, we are providing support for the foundational models like GPT-3 and all. And to be honest, I don't know whether we have specifically GPT-3 or not, but what we really have is you can actually go to Amazon SageMaker examples. And I was actually ready with the SageMaker experiment, so this is how you can access. But just pivoting from here is in SageMaker examples, you can go to the training folder. Sorry, I have to scroll a lot because there's so many features and we keep providing a lot of examples. And then you can go to distributed training. Over here in the PyTorch, with the data parallel, with the model parallel, we actually have GPT-2, GPT-J. So those are examples that you can use on SageMaker Studio. But yes, definitely there is a support for the foundational models, which I'm not sure whether we have GPT-3 or not. But you can check that out.
Yeah, I'll drop in the link to Jumpstart too, just to people can explore on their own as well. Yeah,
going back to the experiments for a moment, I'm kind of curious about. So we can analyze the results of the model, the experiment, to see which was the best fit. But is it possible to actually see what the differences are between the two? The two, like say I did 2 runs and I want to see what parameters changed or what the differences are.
Yes, that's a really good question. So right now we are just evaluating against one metrics, right? But then I want to see what are the differences, like what were the hyperparameters on which this experiment was trained on. So I can actually go and click on any one of this experiment, and then I can look at the parameters. So I have all these parameters that I can take a sneak peek on, and the configuration, the input artifacts. So this one is on the local experiment, which is basically on a local notebook. Let me show you the one, like if you're using a SageMaker training job where the data is coming from S3 location, right? So then you will be able to see like input artifacts. Okay, so this is not the right one. Maybe I didn't complete the training on. It's from last month. Yeah, so this is the one. So you can look at the different parameters, the different artifacts that you have, and you can also integrate it with with SageMaker Clarify and look at the bias reports and explainability reports. I don't think I have those right now ready for with me, but you can actually do that, and then you will see all of this in one place.
Yeah, I was just curious because it's like, I mean, it's great to be able to see, you know, and compare the output of several runs or several experiments. But, you know, I might want to know, why is this one suddenly deviating this way? What did I change that I went the wrong direction or something, right? My head's kind of wrapping around git diff for machine learning, right? Right now, it's like, oh, how could I diff these two to see, you know, give me the total amount of context that I need to know to understand of, did I go down the wrong path, or am I just finding something odd in the data?
Yeah. So mostly it's the hyperparameters, right? That you'll be changing, or the model altogether you might be changing. And if you have like classification problem, you can log these different confusion matrix, or the ROC curves, or precision recall curves, and so on, with just one line of code, and then you can see, okay, what's going on, what's my true label, what's my predicted label, and what's predicting what's going well and what's not going well based on the different parameters. So in machine learning, it's not about that my code will literally change for everything. Sometimes if it's the same model, I'm just changing my parameters. So I need to compare the different parameters. And even when you are running, like you have this table within the experiment, I have different runs, and you can actually see in a table format as well, right? But whatever you feel that, okay, after analyzing it, okay, this is my run and I want to see what were my different other hyperparameters, then you can come back, go to the details of a particular run, and select, see your parameters, and see, maybe it was the hidden channels, maybe it was the number of epochs, right? Or maybe it was the optimizer, which was different than what I was using earlier.
Madi, do you ever use experiments in an ML work, like ML ops style way to tune it? Like, I want to compare how long it takes to train the model running on a CPU versus a GPU. Do you use it for like performance metrics as well, or is it strictly for running experiments against how well the model generates predictions?
So what I do generally is, because when we are saying device like CPU or GPU, it's more about the problem that I'm trying to solve,
Right.
right? For example, if I have a neural network, which is a deep learning algorithm or model, right? And then I say I have let's say 200 GB of data, maybe terabytes of data. Now that's difficult to be trained on a CPU. So then at that time I would select a GPU, right? So that I can train my model very quickly, do some distributed training, take advantage of the bigger machines. But if I'm using a smaller model, even if it's a deep learning model and it's very small, like in this case, I'm using a deep learning model, convolutional neural network, which is a small deep learning model. And it's giving, I know that based on the data that I have, CPU is good enough, or sometimes you can use multiple CPUs, right? So again, I recommend people to start small. And if you don't need a GPU, you should not use a GPU.
Yes, totally. Bad example of what I was trying to talk about, really. But what I'm trying to get to is like, are the experiments more for the fine tuning of the model's predictions, or can you use experiments also to find out a model's performance in training? Right? Is that just not what it's used for?
So I don't use it. I haven't used it for performance tuning. I have mostly used it for, and that's what I've seen people using it for. That, different parameters. How do I see it? How do I do that?
Right.
But having said that, why not? You can actually,
Mhm.
because you are logging the metrics and the parameters as key value pairs, right? So you can technically do that, but I haven't done that with the performance to analyze the performance of my model. When I say performance, I mean the latency, like how fast or
Right.
slow. But
For training, yes.
Yeah, for training.
Yeah,
Okay.
that's what I'm thinking. This is like there's a wider set of use cases here than just the output model accuracy, right? It's performance of it, so on and so forth. Yeah.
Yeah, like accuracy, you can log any metrics like accuracy, losses, and stuff like that. The reason I say that I haven't done the time, like how long does it take? Because with SageMaker, you can actually, like when you run a training job, you can find out the duration of the training job, right? The thing is, how important is it for me to find out the duration of the training job? Like if it's like few seconds or few minutes here and there, is it like an important business factor? Because training is done and then you deploy the model. So
Right.
when you deploy the model, the way you might be deploying it as a real-time API and integrating it with your web application, that's where the latency comes into play more.
Right.
But when you're training, unless it's like, okay, my model is taking 5 hours versus 3 hours, if there's 2 hours difference or maybe 1 hour difference, you might say like, yeah, this is doing faster training than this. Uh, but really, when it comes to training, and if it's like few minutes here and there, but one model is giving you better accuracy or better loss, you technically tend to go with the metrics in that scenario.
Totally. Makes a lot of sense. I was just curious. I know ML ops is a big, emerging thing too, and I was just curious if this had any relation to it. I was a novice to all of this.
So it has a relation to the ML ops, right? So
Right.
when we say ML ops, we are operationalizing or automating our
Yes.
life cycle, right?
Deployment. Yeah.
Exactly.
Yes.
So then I can say that, okay, I've automated, I've coded for this particular model, and now to find the right hyperparameter, let me just plug it in with my operational lifecycle or create a pipeline around it, and then it can automatically create the experiments and find the best one, and then maybe deploy the best one to the QA environment.
Yes.
And I don't want to babysit that, so then I can integrate it with my a SageMaker pipeline, if you're using SageMaker pipeline or the CI/CD pipeline, the way you are automating it. So in that scenario, experiments, yes, it does make sense.
I love
But
it.
that particular aspect, where you're trying to find the time duration of the training, that again depends on your use case, depends on how far away those durations are.
Makes sense.
Yeah.
Cool.
Yeah, and also for like sometimes when you evaluate the model and do you want to retrain or not. So those also are few examples where I would say that experiments is a good idea to look at.
All right, Mani. I think we are running close here on time. Do you have any parting words for our audience of where to learn more about SageMaker experiments? Any tips on getting started, with SageMaker in general? Anything you want to leave with the audience before we've got to move to our next segment?
Oh yeah, absolutely. So please check out the SageMaker Experiments webpage. And once you look at it, also SageMaker Examples GitHub repository, you go to the SageMaker Examples and then SageMaker Experiments folder, and you have the code that I was showing you, and you have other codes if you're using TensorFlow. We have code for that as well. So definitely go try it out on your own, provide us feedback. We are always listening and always working backwards from our customers. So we really value your feedback. Thank you so much.
All right.
Super helpful. Thank you so much, Mani, and thank you for being patient with I'll just say my novice questions here.
I think we're both ML noobs here.
Yeah, for sure. So thank you very much, and taking the time out to help educate us and all of the viewers as well.
No, thank you so much for providing me with this opportunity, and have a great rest of your day. Thank you.
You too. Hope you'll come back in the future.
Yeah.
We'll see you.
Absolutely, always here. Bye-bye.
Talk to you later. All right. Well, I know a little bit more.
Yes. Every AWS on air, I learn a little bit more ML.
A little bit more.
Just a little bit more.
Yes, totally.
But then I realize how much further I have to go.
I know. It's the Dunning-Kruger effect, right? Have you ever heard of that before, Steve?
Yes, I have. Yeah.
Once I heard about the Dunning-Kruger effect, it made me feel a lot better about myself. Where you understand, and then you hit this.
And then you shoot.
Yeah, and because you understand enough to know that you actually don't understand it
enough. Yes.
And then gradually that line starts coming back up, but usually gradual.
In my case, it's a very, very slow ramp.